This is Sky recording live from Twitch TV, and we're in the saddle once again. Stop laughing! So, yesterday was kind of a goofy day with the weird package naming messing with the compiler. So, I had a second thought about it. I mean, we're still going to test it and still going to write the same thing, but I'm actually going to work on it from the backend side first and get that set up so that we run our tests. We can test against the actual socket. Not really a big fan of that idea, just because of they start to couple the services together, at least down to the socket level. We could also mock it out. So there's a couple things we can do. But I didn't want to mock it out because it just adds another layer of implementation, like function calling. As far as the performance thing goes, we'll see how it goes when we get there. But we're going to be back here and taking a look at the. Hold on one moment. Taking a look at the server side of things. I'm actually going to break this down to multiple projects, so that we'll have like different pieces. So let me pull this up real quick. All right, so here we go. So we have our game here. So I'm actually going to remove all this. Didn't really do anything with it anyways. And now going to mix new. We'll call this the game server. And this is, we're also going to create one that's basically like a web service type thing, which is just going to be the lobby. Next new lobby. So we have two separate, actually, I'm going to move that. I'm going to use a Phoenix project. So what we can do, so Phoenix is a web server for Elixir. It's called the Phoenix framework. It's a bit like Rails, but better. So take Rails and then make it 200 times better and usable. So that's Phoenix. It's really, really fast. It takes all the advantages of the Erlang VM. We can network them. There's all kinds of better things. So we're just going to go over here to the installation. We can get Hex, which I think we should know the latest. Replaced it. And then got this all installed. So now we just need to copy this and we'll get the latest Phoenix framework. And it asks us for the latest, yes. And now we just do mix Phoenix new. We'll call it lobby. And we get all our dependencies right now. And it also installs Node for some library reloading. But we're not going to play too much with this quite yet. Once we get into some more like the lobby stuff, like when you log in and you create your character and all that stuff, that'll all happen through this service. The game servers are actually the actual battles will take place, and so we can scale those horizontally as we need to and have lots of players playing at once, and that's what we want. So what I'm going to do, the more and more I think about it, I think I'm going to abstract out socket connection. I don't know. It goes both ways. I do want to make sure that these two can talk to each other very effectively. So let's go into the game server for now. And we're going to create, just run our test real quick. And there's a library that we use for mocking and Erlang, which is mech. And we're just going to see. Oh, you know what? I thought it was not. That's not mech. It's Elixir mock. Mech is for Erlang. There's a mocking library for. There we go. It's called mock. It actually uses mech. So we're just gonna copy and paste this. So down here in our dependencies, we just paste our dependency right there, and then mix deps.get, and that'll actually get our dependencies. We're ready to go. As you can see here, installed mech anyways. So Erlang and Elixir work together very closely. And so what we're going to do is we're going to create a directory called game server lib game server, and we're going to call this the socket server. That seems reasonable. And there's no classes in functional programming. We just have modules, and you gotta think of functional programming. It kind of helped me think through it. It's a lot like running bash commands. You just do a lot of small programs that work really well, really tightly, and it kind of feels a bit like coding with nothing but static methods, which sounds like trouble, but it's actually way socket server, way easier to deal with. Okay, so what we need to do is, come on, I'm trying to think. We need to, I think we want to do a listen, and we're going to give it a socket. So we always need to pass what we need. Everything's immutable. We'll kind of get into this more and more. So now we're going to go to vi test. Oh, we need to make a directory. Do this game server. And what we need to do here is we need to do game server socket server. So it's kind of like the name spacing. Game server, game server, vi test, game server, socket, server, test, exs this time. That means it's going to be interpreted. It stands for Elixir script. And what we're going to do, I'm just going to copy in an existing test to get us started. So game server, oops. So our test game server test. So game server dot socket server test. And there we go. And now we need to import mock. Import mock. And now we can run our tests here. So test should have two passing tests. Undefined method mock. Oops. Oh, I'm going to E. There we go. Next test. So we should have two passing tests. There we go. So now, say we should do test connect or listen for a socket connection. In fact, we'd probably do accept a socket connection. Okay, and we don't need this anymore. And now, what we're going to do is we need to mock out the actual socket. So we say with mock, and we want to use, what we need to do is we need to edit our mix file, and we're going to add our socket. So this is going to be socket, and we're going to do greater than or equal to, not greater than, just greater than 0.3.2. So now we can run mix depths get. There we go, so we got our socket ready. So with mock, there. With mock, we're going to do socket dot what we need is we need a port. So socket dot web, and should we have it all work here? Let's look here. Live game server, file server. So we passed it in a socket. We should probably pass it in a port number. And we could technically handle it all here. Let's see what happens. Okay, so let me think through this. If we want to, so what's going to happen? We're going to receive we're going to set up our socket listening. We're going to receive a socket from that player. Then we need to find a way to uniquely identify that socket if we needed to. So we need to assign some sort of identifier to it. And then we need to store it. So likely what we're going to do is we need to store the socket state someplace. This could be a good place for it, which means we're going to need another library. We can look at mix. I'm going to use one called Exactor or Xactor. So this will help us with our state with OTP. And so I don't know what this means. I've never seen that before, but we'll add it. This will help us with our state management with OTP. And OTP just stands for Open Telecom Protocol, or Open Telecom Platform. And that's about all it is. It's just a name. And all it does is it helps us with our state management and distribution in Erlang. Makes things a lot easier. So we're just using a macro library that makes it a little bit easier to work with. We could just do these def start, def cast, def call. It's a lot easier to work with than having to do def, remember the signature and everything. This works surprisingly better. So we're going to go back to our game server, socket server, and all we need to do is we need to just use the Exactor or Xactor. I kind of like calling it Exactor. Babe, what sounds better, Xactor or Exactor?
Xactor.
Xactor. Okay, so she has spoken, so let it be written, so let it be done. It is now officially Xactor.
What about eggs actor?
Eggs actor?
Yeah.
It's not really spelled eggs. So I don't think that's going to work. So what we need to do is we're going to def start link, and our initial state will just be a map for now. So thinking through it, once we accept the socket connection, when we receive, we need to be able to, I don't know if we'll need to store it here. I'll keep going, just to, actually let's ditch this for now. I'm trying to think, how do we want to handle this? I feel like what's better is returning the port, and then we can have something that's handling the processing of the data, which I kind of like that. So all this is just going to establish the connection, and we can also do closing the connection. this works. All right, so the socket web listen, and I think, let's go back here. We're going to this is the function that's going to be called listen, and then this is what we're going to call instead. And what we need to do is return a, so there is no, well, this would be our port number. And what we need to do is we need to return a, let's find out here, IAX-S mix. If we do mix-get IAX-S mix, hold out our socket library, so server equals socket web listen permission. Oh, we don't want 80. We want sorry, 9999. So this is going to give us a socket web. And so what we need to do is we're going to say def p get. Actually, we want TCP. And that just gives us a port. So we actually want socket. We want a TCP socket, and that just gives us a port. And so I think what we can do is we can say port equals, we'll just give it a map for now. And back here we are going to return the port. And do. Okay, so now we have that. We should be able to talk to the game server. So I'm going to take this out. We're going to use this later. So say we're going to alias game server socket server. So now we can just say socket server. We're going to have to do the oops, we don't have to do the game server.socket server anymore because now we've aliased it. Listen. We should do that because it does not return a status. Come on. There we go. Listen, and we're going to give it a port 9999. And that should give us a return port. And then a search port is equal to return port. And so that gives us our listen. But we actually want to accept as well. And I believe accept returns us a port as well. So what's interesting here is if we accept port, we've just all we did was put a direct thing in front of socket, which I don't like. Let me think. I feel like we should actually just call this a socket acceptor. No, I think this is okay. Socket. So once we accept, let's return returns a port for the client connection. Okay. So what we need to do is this will actually starts the server listening. Okay. So it is kind of a wrapper around it, but it really is going to change when we get to this part, when we return the port. So if we can't return the port, we need a function to call. So the idea is we're going to have there we go. The idea is we're going to have a recursive loop to this accept. So it's going to be, in fact, we should probably call this server. So if we do server, so first of all, let's get this listening happening. Okay, so we're going to socket TCP listen on port number. So this should give us our passing test. And didn't have it fail first, so let's make sure it fail. Okay, good. It does fail first. There we go. So now that we have our listening port, I think, let's see here, if we do this again, it actually just throws an error, so we can't actually, oh, actually if we want to do it this way, yeah, let's not do exclamation point. So we'll get an OK and a port. This is much better, I like this better. Okay, so here we're going to return a tuple, which is going to be OK, and our port. And we call this, and make sure we pattern match on the OK, and the return port like so. So this will probably not even compile. Oh, actually, it'll still work. Next test. Game server, socket server, let's see, did I not save this? Okay, so on here we needed to return, oh, it should be okay. What was the problem? Next test. So start port equals return port. Left hand side is okay, and right hand side is just the map. Oh, okay, yeah, so we can just pattern match against both. Why not? So that'll work. There we go. So now we get our port, and now we need to say test return already in use, if port is already connected, already open, already listening. So here, we're just gonna grab these, yank, put, delete, and we need this exact thing, error address in use. And now, those need to equal, which isn't hard, and should pass. Okay. Now, this is where the interesting thing happens, is we need to accept the server. And this is the part I'm still trying to decide how I want to do. Because we want to have the server return a socket, but we also want it to call itself. And so it keeps accepting connections. What we could do is we can create another module, which is the socket acceptor. And I'm kind of okay with that. So that's what we're going to do. So we're going to create a file called name server socket acceptor. Acceptor? Is that even a word? Acceptor. Yeah, okay. It is a word. Socket acceptor. Def module socket acceptor. Do, and there we go. I'm going to say def socket connected, and we're going to get this called with our port when it gets connected. You can also do socket closed, and we'll have that event as well. So basically it's going to handle our events. Now, I think what we can do now is we need to set up a mock to assert that that was called. I think we can do this. Let's do test with mock should pass the client connection to the socket acceptor. And I believe if we do accept, that would be an OK as well. So do, let's take a look at this. We're going to give it the module that we need to mock, which is socket TCP, and then on the accept, this one we're going to just do that. Let's think about that one. Okay, so accept, and the function is going to be the, let's go edit this again, edit lib game server socket server, oh no, socket server, okay. This gets a port called server, and that's going to return a port end. test with mock. Oh, we don't do here. We do here. Okay. Oh, we do have that. Okay. Now, on our accept, we'll have a port. Call it I'm going to call it the client. Client port is equal to that. I wonder if we can actually make it a port. That's not going to work. So we'll just keep it as a map. Keep it as a port. And, or a map. Now we need to do with mock, we're going to alias socket acceptor with mock socket acceptor, and we're going to get the function lib name server socket acceptor. We're going to get socket connected. In fact, I want to do, instead of socket, I want to do client accepted and client closed. I like that much better. Okay, so it's going to be client connected, and the function is just going to be the client connection. And we're just going to do nothing with it. So we just call, let's give it a nil. Doesn't really do anything because it's just going to hold on to it. End. And that should do it. Do end. I hope we can do this double level of mocks here. So now, socket server accept port the socket server accept server. So yeah, give it the port, which is this port up here, this piece, not the status. So socket accept port, and then we say assert called socket acceptor dot client connected with our client. So one more thing, we need a client port. There we go. So see if that builds. Syntax error before do. Oh, that doesn't make sense. So, how does this do this? Looks like this is not going to work. So we're just going to do test. And we're just going to follow the same pattern here, because we need to have a reference to these two. B1. So with mock socket TCP. Going for accept the server, do end, and let's pray that this will work. Next test. Unexpected token end. We need to set our do here. And undefined module, game server socket acceptor, game server, the game server socket acceptor, game server dot. There we go. Undefined function game server socket server accept 1. So I think we want to do this. And expect really got false. We didn't ever get our client connected. So now we can actually implement this. So lib game server socket server socket server. Now we can actually implement this. So we get our server and our client is equal to server socket .tcp .accept. Boom. And then what we can do is we need to make a recursive call to this. First of all, let's finish this out. So we're going to say alias game server socket acceptor socket acceptor client connected client. We could probably roll this all up, but next test. There we go. We're successful there. The interesting thing is what we need to do is we need to call the accept again. Like this. And I don't think it'll actually, yeah, so it's just going to hang. So what we can do is on our second accept, so maybe this is a actual good thing to do. So let's go back here. On our, we want to run accept. Return our client. This is going to return OK and a port. So we actually want that. And oops, I want to do it this way. This actually doesn't return anything. It's essentially just a recursive call indefinitely. To accept clients. And maybe that's not up to this to figure out. We'll just leave it at that. So if we do this way, we haven't really done anything. Because we're going to have to test that eventually. Let's go back. So now that we have that, I wonder if we can do I haven't tried so much with this mucking library before. So what we need to do is we need to, when it calls the first one, do one thing. When it calls the second one, do something else. And so we can tell it that if we get the first accept, return OK. When we get the second accept, to escape out. So essentially, I wonder if we can just do like this. And we accept the second time. We return error. Closed. And that's probably not even the right thing. So let's do socket. So if we get server equals socket.tcp close. There's no fucking TCP. Let's see here. Socket TCP. There's connect, listen, accept, process, options, arguments. Not seeing a close. Listen, connect, error. So that's not that useful. Socket. Connect, listen, arguments, send, linger. Arguments equal, accept, passive, local, remote, close. Okay, so if we do socket close. Socket. I wonder if we do close? No. Socket protocol tuple close. I would think it'd be that. Oh, we probably need the port server. Port. No? There we go. It returns OK. So now if we try and accept server. Let's see here. Alright, so let's try this again. So let's listen there. So they give us a port. And what we need to do is we need to get our port from it. And now we're going to close it. And now we're going to accept server. It just returns as an error. Don't like the way that works out. So let's see here. Let's do port. There we go. Connection's closed. There we go. Error closed. And I just randomly guessed it. Can you believe that? Alright, so we're going to need to make sure that that escapes. And now what we can do is we can do a tuple, which is our status, and our port, client port. And now we can say, gosh, I forget the syntax. Elixir it is case of status do end, and in the case where it's okay, we're going to take this and then for the case for error, we're going to set nil, and for every other case return nil. Okay, and then here we're just going to call this accept. Hopefully smoking library does the way we want it. Syntax for that. Test 27. Oh, it's a tuple. Okay. All right. Already started. Game server test line 29. What's this? So it looks like what we need to do don't think we can do this. So this will work. I'm not that excited about it. But we can do this. We can do error closed. And we can do client equals how do we want to do this? We do I wonder if we can do this. Do client will be tail, and we're going to turn client head. Next test. Truthy got false. Okay, so at least it exited. And so that's good. Gives our test life 35. So here, let's this is not going to work. Let's see here. Put return value. This will work. Mix test. Ah, close. Truth, you got false. Called connected client. Oh, we should get okay with this. Technically, what do we want to return this as? We just want this. We don't want the tuple. See if we can get some visibility into this. IO inspect batch val. So that one returns okay. And then, let's see here. IO inspect status, IO inspect client. So it gives us, that's correct. I wonder if it's because we should do port. We don't really need that to be something specific with port. Let's see here. Is there any more information we can get out of this? Batch client. So it's actually not calling that function or this match. In fact, I think it's because of this. It's expecting a tuple, but really we just need an atom. I think that's it. Ah, hangs. Darn it. IO inspect client. IO inspect. There we go. It's always returning that one. Let's see here. Client. I think it's mostly because it's out of the scope. It's out of scope at that point. What can we do? That's a tough one. Because we need to... So what's going on here is that this is not in scope anymore. So we're just grabbing the head, we're assigning it, but it's just going to be lost as soon as it gets called again. Because of this is not actually in the scope. To prove that, put that here. We'll see it like that. So, how do we keep it in scope? Is there like a then? This seems like a short-sightedness of the mock. Test with mock. So with mock, we've got options, mocks. Mock module with function specified as a keyword list of function name implementation mocks for the duration of the test. List of optional passive mock, pass-through. So that's not what we need. Mocks. I don't know what the list is for. Mock module, which function specifies keyword list of function name implementation mocks for the duration of the test. So I wonder if we can do this. Let's try this. To do success closed. Error closed. Now, if we do here, we do success. I wonder if this will work. Except function server closed. Oh, I hope this is it. No, but it did exit. So what's going on here? IO inspect status. Error. So it seemed to have accepted the second one. That's a bummer. This is definitely a tricky situation. So, out of curiosity, That's what happens when you're doing it live. You run into all kinds of things. So that's infinitely okay. Darn it. Why can't you call the next one? See here. See if there's anything in the test that can give us some. if we call the same function multiple times, string downcase do. No, they're not doing that. They don't even have a test for it. So that's a bummer. Is that in their list of issues? Versions to share for multiple knocks. Mocking exceptions. Doesn't look like there's any help there. Let's see if there's anything here. So with mock, module option mock, do test. Test with mock. So let's take a look at mech. Mech. Pass through, so we get pass through there. Interesting. So dynamic return values sequence lives static values, compact definition mock arguments, clauses, and return values. Complete history of showing calls, return calls, and exit mock validation with validate. Doesn't matter when mocking a module that doesn't exist or has been renamed. Hamcrest matchers. Dynamic return values using sequences and loops and static values. Okay. How does that work? Don't think that's going to be much help. So let's go back to this. With mock socket TCP accept function server closed and do. Let's try this approach. And so already started. So it comes up as a process. It's so weird. Okay. This is really, really tricky. We could use an agent. The last thing I want to do is store state, and that's what kind of sucks. So, oops, Elixir agent. So we need to set up abstraction around state, which is kind of dumb, and I don't like it. but it looks like it's our only option at the moment. I figure out a better solution for this. So agent.start link actually haven't used an agent in forever. Get start link, okay. Performs a cast, gets an agent value by a given function. So start link agent get module function. Okay. So we'll do what we had before, which is this list be a success, and then name is module. Well, we'll just call it accept test. So just need a string name, and then here we're going to say so status or return val equals agent dot get accept test function item in set. Get an update. Get and update. Accept test and list and I actually don't like this syntax. I like to do this. So now we don't need this. What is this? Enum into set. Let's just get an update. When A is var. Okay. Gets an update to the agent in one operation though. So it's the return value, which is client head. Sorry, success head. That's wrong. It's list head and then list tail. Come on. Define function closed. no cause matching except test. I wonder if we do this. Module. Oops. There we go. It actually worked. Wow. Okay, that was kind of excessive. So line 11, we've got port number. So this is not needed. Oops. This is unnecessary as well. Let's test 29 and 34. 29, this is unused. And this kind of connection is unused. There we go. We did it. Wow. Okay, so to sort of reiterate what we did here is we created the port. That's nothing really exciting new. We created our states. So I'm actually doing this our states. So the first response, we were expecting OK port. Second response, error closed. So we actually exit our loop. Otherwise, we wanted to continue forever. So when we started our link with the agent, we passed it our initial state. I'm going to add this here so we know that it's a function call. We give it the state, the initial state to work with. This is what this is all about. We just gave it state. It's expecting a function, so we can't just give it state. And we give it a name, which is underscore underscore module. Underscore underscore just refers to itself, the self module. And then we set up our mock finally. So now when we get our accept, it actually gets an update. So we just pass it the module itself so we know what process we're talking to. That's a Erlang thing. And then it passes in our list, which is technically our states that we passed in the first place, this thing here. And then we return a tuple. The first side of the tuple, the first of the elements, we basically grab the head, which is this, and then we updated the state, which is the tail of the list, which is this. And so it stores the new state as this. So when we call this, we call accept. That returns our first state here, which is our OK. And then it'll call it again, and it'll grab our error. So if we actually trace this out, we actually get nil, because that's what we returned last here, which is this. So, oops, mix test, you'll see I changed something, states. You'll see it's nil, like I said. So, it was really clever to get around that. So now I know we can actually set up agents. That's kind of cool. So let's commit this. So we're going to quit. We've got our socket working. Okay, and now we're going to say git status, git init, git status. We're going to add one more thing to the git ignore, which is the swap files that Vim generates. Git add git ignore, oops, git ignore, the readme, the config, the lib, the mix files, and the test files. Git status, git commit, and we're going to say that our initial socket accept or socket server connecting these sockets. Boom. Get tag date. Get tag 2016 for 28 08 53 53. Weird. There we go. Thanks for bearing with me. It was definitely a battle of the wits, and we won. So that was great. So tomorrow we're going to continue this on. We're going to keep building out our socket. We're going to build out a server, and we're going to have a fully networked game by the end of it. So have a great afternoon, and I'll see you guys tomorrow. See you later.